it's actually based on the velocity of your particles. So if we go to speed and we drag the speed down, you can see not only do the particles not travel as far, but you can also see that the lines shrink in response to the lower velocities. So that's obviously a very useful option for when you want to get an idea of how fast your particles are moving. But with very, very high velocities, you can get very, very long lines, as you can see here. So that's something to be aware of. I'll just put it back down to something a bit more reasonable. The next option is bounding boxes. Bounding boxes, and as you can see, you get bounding boxes of the size of your particle. Now that's actually based on the shape which we have here. If I turn off the shape, there is no actual scale or size to the particle, and so the bounding box option doesn't really make any sense anymore. And you can see, because it doesn't make any sense, particle flow has actually replaced the bounding boxes with these crosses, which basically indicate it's not getting any real data to base its bounding boxes on. If I go down here and I grab a scale operator, I'll just put some random scale onto these shapes, and I'll just do that here. I'll just scale them down a bit. So there you go. You can see that's a really useful option. The bounding box option gives you a display of your particles. You get an idea of scale, but you don't have the full geometry to display. The next option is geometry, and that will actually display the full geometry of your particles. So if we picked a teapot and I turned off shape sphere, obviously that's just a normal shape operator. If I go along and I choose shape instance instead, pop that in there, and if I pick this teapot, now you can see I'm displaying the full geometry of the teapot. And if I crank that up a little bit, make the teapots a bit more detailed, and press play, maybe got a little bit excited there with the number of segments. I'll just wait for Max to come back from that, and then we'll put it back down to something a bit more reasonable, like 12. There we go. Now if I press play, there you go. It's slow as anything. You really wouldn't want that. So you've got to be careful with displaying particles as geometry. It can get very, very heavy. Even though the particle simulation itself is very, very, very simple, displaying all those particles, the geometry of them, can get very, very heavy in the viewport. So in this particular case, I would probably go back and use bounding boxes, and then I'd have the full speed. So that's something to bear in mind when you're using the geometry option. Just get rid of this teapot, and actually no, we'll keep that. I'll just put that back down to a lower level and scrub on a bit. The next option is diamonds, and that's just a very simple shape, diamond shape, which also can be useful. It's quite similar, I suppose, to the circles. You have boxes, again a very simple shape. Asterisks, which obviously you can see instead of being a cross shape, it's actually it's got two crosses superimposed on each other. That's obviously quite a dense particle. So in terms of density of crosses, you've got dots, ticks, and then you've got asterisks. There's a sort of logical progression between those types. And the last option is triangles. So you can use any of those display options as you see fit. They don't have any effect on how your particles will look at rendering time. So if we click on render here, you can see at render time you get your full geometry rendered. So let's move on to the next option. The next option you have in the display operator is the percentage of the particles which are visible. You could put that down to a lower value and actually just display a subset of the particles. The next option is show particle IDs, and that actually shows the numerical ID value of every particle. So the first particle will have an ID of 1,